let's click here to show our files. And we're actually going to make a copy of the project just for this lesson. So we're going to right-click this file, copy, and then at the bottom, right-click and paste. And we're going to rename this file. So right-click, rename, remove copy at the end, and then at the beginning, we'll change this to 07 and press enter. Next, we're going to open this file in Live Server by right-clicking and then open with Live Server. And let's also open the console on this page. We'll right-click, inspect, and then click the console. All right, now if we look at the code for generating a computer move, you'll notice that this code is the same for all three buttons. So this is a perfect situation to use a function, because a function lets us reuse code. So let's scroll down to the script element, and we're going to make a function here. So let's type function and then a function name. Let's name this function pick computer move, and then brackets and curly brackets. So one recommendation for function names is to use a verb or an action in the name, such as pick. So next, we're going to move all the code for picking a computer move into our new function. So let's create a new line here, and we'll scroll up to the scissors button because it's the closest one, and we'll select all of this code for picking a computer move, and then right-click, cut, and inside the function, right-click and paste. If we need to fix the formatting, we can select these lines and press Tab to add indents. So the reason we created this function in the script element is because remember that the script element runs when the page is loaded. So we want to make sure that we create the function first, and then we use it in the buttons after. Now remember, this code just creates a function. It doesn't actually run the code inside. To run the code inside, we're going to call this function. So let's scroll up to the scissors button, and we're going to call this function by typing the function name pick computer move, open bracket, close bracket, and semicolon. If we save and then click the scissors button, unfortunately, it now gives us an error saying computer move is not defined. Now, this might seem weird because down here, we actually create the computer move. So what's going on? The reason this happens is because functions create a scope. In the previous lesson, we learned about scopes, which limit where a variable exists. We learned about if statements, and that if statements create a scope between the curly brackets. This means that any variable created between the curly brackets only exists between the curly brackets. Functions also create a scope. Any variable that is created between these curly brackets only exists inside the curly brackets, and we can't use it outside the curly brackets like we do here. So that's why we're getting this error. So how do we solve this problem? Remember that with if statements, we solve this by creating the variable outside of the if statement, like this. We can use a similar solution with functions. To make this variable exist outside the function, we just have to create it outside the function. So let's select this code we're going to right click and cut and remove these lines. And then outside the function, we're going to right click and paste. So now this variable is no longer inside the function's scope, and it can be used anywhere else in the code. So variables like this that can be accessed anywhere are called global variables. If we save and now click the scissors button, everything is working again because this code above can now access this variable. Now let's press OK, and let's use this function to reuse this code. So we'll scroll up to the paper button, and now instead of all this code again, we're just going to remove it and call the function pick computer move open bracket close bracket semicolon, and also with the rock button. We'll select all this code and remove it and just call the function pick computer move brackets and semicolon. Now if we save and click the rock button, it works just like before. We'll press OK and click the paper button. It also works just like before. So as you can see, functions let us reuse code, and they make our code a lot cleaner by removing all the duplication that we had. Another benefit of removing duplication is that before, if we ever wanted to update the code for picking a computer move, we had to update it in 3 places, in each of the buttons. But now, if we scroll down, we only have to update it in one place, inside this function. So functions also make our code easier to update in the future. Next, we're going to learn a feature of functions called a return statement. A return statement lets us get a value out of a function. So at the end of this function, let's type some new lines, and we're going to type return, and then a value, like the number 5, and semicolon. Now, whenever we call this function, it will result in a value, the number 5. So up here, when we call this function, this will result in the number 5. So we can actually console.log this, console.log, and then save and click the scissors button, and it will show us that calling the function now results in the number 5, and we display it in the console. So that's how a return statement works. It lets us get a value out of this function. Let's press OK and do another example. We'll scroll down, and this time let's change this value to the string rock. Now whenever we call this function, it will result in the string rock. If we save and then click scissors and scroll up here, calling this function now results in the string rock, and then we display it in the console. So now let's press OK, and we'll learn the syntax rules for a return statement. So we just have to type the word return and then a value, and it will get this value out of the function. Now, instead of just a value, we can also return a calculation or a variable or anything that results in a value. So this is known as returning a value from a function. And this value is known as the return value. We also don't have to return anything from a function. If a function doesn't have a return statement, or we return without a value, like this will return the value undefined. So if we save and then click scissors again, the function will return undefined. And lastly, when we use a return statement, it ends the function immediately. So after the return statement, if we type console.log the string after and press OK here and save this file, and then click the scissors button, notice that it doesn't run this code. And that's because once we return, the code returns back to where we call the function. That's why it's called a return statement. So it's not going to run anything after the return. So we can remove this code and press OK. So now that we understand return statements, we're going to learn a better way of getting the computer move out of this function. So first, let's actually move this variable back into the function. So we'll right click and cut, and then in here, right click and paste, and delete these lines. So now we're back to the original problem. How do we access computer move outside of the function? So another solution is to return this variable, because remember, a return statement lets us get a value out of the function. So down here, we're going to return the computer move. So this will take whatever value is saved inside computer move, which is one of these values, and return it out of the function. If we save and then click the scissors button, we were able to get the move scissors outside of this function. So what happened here is that we returned this move, and then up here, we took the move and displayed it in the console to get scissors. So that's another way of getting the computer move out of a function, using the return statement. However, now we're back to this problem with computer move not being defined, because we moved it back into the function's scope. So let's scroll up, and remember that this return value is just a value. We can use it like any other value. For example, we can console.log it, or we can also save this in a variable. So let's do that right now. We're going to remove this and create a new variable with const, and let's just name this variable computer move to match what we use down here. And we'll use equals to save the return value inside this variable. So note that even though we use computer move here as well as here, there's different variables. This one is inside the function's scope, so it prevents it from conflicting with variables outside the function's scope. That's one of the main benefits of scopes. So now that we save the return value into this variable, and we're using this variable down here, the code should now work. If we save and click scissors, everything is back to normal. And let's press OK. So don't worry, functions can be a little confusing at first, because the code is no longer simply going from top to bottom. It sort of jumps around a little bit. So let's go through this step by step. When we click this button, we're going to run this function. So the code is going to jump down here, And then it's going to run all of this code from top to bottom. At the end, we're going to return whatever is inside computer move back to where we called this function. So we're going to return all the way back here. And then we're going to save that return value into a new variable, computer move, and then use computer move down here. So following the code line by line like this is called tracing the code. It's a useful technique to understand exactly what the code is doing. Now let's compare the two solutions that we used, a global variable and returning a variable. So returning a variable like this is actually preferred over using a global variable. And that's because a scope can help us prevent naming conflicts. So all the variables inside here will not conflict with anything outside the scope. So generally, it's a best practice to keep things inside a scope if we can. Now let's move on and use this function in the other buttons. Feel free to pause the video if you want to try it yourself first. So we'll scroll up to the paper button, and then here we're going to save the returned computer move into a variable. So const computer move, so that it matches the code down here, make it equal to whatever is returned. And then same thing for the rock button. We're going to save the return value in a variable const computer move equals. If we save and click the rock button, it works. Let's press OK and click the paper button, and this also works. And let's press OK. So that's how we use a return statement to take advantage of the benefits of scope. Next, if we look at the rest of this code, where we compare our move and display the result, you'll notice that this code is very similar for each of the buttons. The only thing that's different is the result and the message that we display. So we can actually use functions here as well to reuse code that has small differences. To do this, we're going to need another feature of functions called parameters. So let's go back into functions.html, and let's open the tab for this file. And let's also comment out the previous code by typing /* and at the bottom */ and create some new lines. And now we're ready to learn parameters. So parameters are sort of the opposite of a return statement. A return statement gets a value out of a function. A parameter puts a value into a function. So let's do an example. Let's say that we're working on the final Amazon project, and we need to calculate the tax for our order. Let's create a function to calculate the tax. So function, let's name it calculate tax, brackets and curly brackets. And then inside the curly brackets, let's say that the cost of our products is 1,000 cents or $10, and the tax is 10%. To calculate the tax, we can do 1,000 times 0.1, which is 10%. Let's also display this number in the console. So at the front, we'll type console.log and brackets. Now let's save. And remember, this code only creates a function. It doesn't run the code inside. To run this code, we're going to call this function. So down here, we're going to type the function name, calculate tax, and then brackets. If we save, it runs this code, and then it displays the tax, which is 100 cents or $1. However, right now, this function only calculates the tax for 1,000 cents. What if we want to calculate the tax for a different amount? How would we modify this function to work with any number? To do this, we're going to learn a feature of functions called parameters. A parameter lets us put a value into a function. So let's finally create our first parameter. So inside these round brackets, we're going to choose a name for our parameter. So let's just name this parameter 1. A parameter works the same way as a variable. We can save a value inside this parameter and then use it just like a variable. So first, let's save a value inside the parameter. To do that, we're going to go to where we call the function. And then inside these brackets, we're going to put a value. For example, 2,000. This will save this value into this parameter. And now we can use it just like a variable. So instead of 1,000, we're going to type parameter 1. And it will take whatever value is inside parameter 1, in this case 2,000, and substitute it into the code. If we save, it now calculates 2,000 times 0.1 to give us 200 cents as the tax. Now, every time we call the function, we can save a different value into the parameter. For example, let's create a new line and call the function calculate tax. And this time, we're going to save the value 5,000 into parameter 1. If we save, this line of code will calculate the tax for 5,000 cents and result in 500 cents. So as you can see, a parameter lets us put values into a function, and this allows our function to work with any value. Now let's learn the syntax rules for parameters. To create a parameter, we just typed the parameter name between the brackets. Parameter names follow the same rules as variable names. We can't use special words, we can't start with a number, and we can't use special characters other than $ and underscore. And the best practice is to use camel case. Let's actually change this parameter name to cost so the code makes more sense. And save. Next, when a function has a parameter, we usually say this function takes a parameter. If this parameter should be a number, we say this function takes a number. When we put a value into the function like this, we call this passing a value into the function. Another name for this value is called the argument. And believe it or not, we've actually used functions and parameters this whole time. The first code that we learned in this course was alert. Alert is actually a function. You can tell it's a function because of the round brackets. And between the brackets, we put a string. So this is an example of a parameter. And lastly, a parameter only exists inside the function's scope. So we can only use this parameter between the curly brackets. We can't use it outside the function. Next, a function can actually have more than one parameter. For example, right now, our calculate tax function can only calculate a 10% tax. But what if we're in a different country and we want to calculate a different
Qué feo
tax
eres,
percent.
catorrazo.
To solve this, we can add a second parameter by typing after the first parameter a comma and then another parameter
Tengo
name.
todo el equipo listo.
Let's
Solo
name
necesito
this
unas bombas de azúcar.
tax percent. And now to save a value into the second parameter, we'll go to where we call this function and also type a comma and a second value,
Muévete,
like
carne.
0.2
Y sí, veo que no le quitas
or
ojo.
a 20% tax. So the first value gets saved in the first parameter, and the second value gets saved in the second parameter. And now we can use our second parameter just like a variable. So instead of 0.1 every time, we're going to calculate it with tax percent. And it will substitute whatever value is inside tax percent into the code. If we save, this first line will multiply 2000 by 0.2 and give us 400 cents as the result. So we can have as many parameters as we want in a function.
Tienes tus cositas
We just
y
have
yo
to
tengo
separate them
Es
with
una
a
combinación
comma.
divina.
Now notice that the
Bueno,
second
¿qué
time
me
we
has
call this
traído?
function, we didn't give a value for the second parameter. If we don't save a value
Claro que
into
sí.
the
Yo no me
parameter,
acerco a ellos y a
the
cambio
parameter
ellos
will
no me
get the
molestan,
value
así que no hay ningún
undefined.
problema. Viven como
So
hacia el
here,
este. Por
if
si te da
we
vergüenza o algo, creo que hay un pasadizo subterráneo hasta su
console.log
asentamiento
the
al fondo
second
de la
parameter,
estación de metro.
tax percent, and save, it will show us that the second time
Sí,
tax
haz lo que
percent
debas.
is undefined. And then
Sí.
multiplying
¿Tienes algo que
the
decir?
cost times undefined is not valid math. So we get the result nan, or not a number. So now let's remove the console.log and we'll learn how to fix this. So to fix this, we can either
Tengo
pass
todo el
a
equipo
second
listo. Solo
value
necesito
into
unas
the
bombas de
function,
azúcar.
like this line,
¿Cuál es la
or
gran idea?
we can also set a
Muévete,
default
carne.
value for the parameter. To set a default value, we can just type after the parameter and then add equal sign and a default value, like 0.1. Save. The second function call will multiply 5000 by the default value 0.1 and give us 500. So that's how we add a default value for a parameter. Alright, now that we learned parameters, we're going to go back to the rock, paper, scissors project and reuse even more code. So let's go back to the file for the project and also the tab for this project. And now, if we look at the code inside each of the buttons, you'll notice that the code is basically the same for all three buttons. The only small difference is the move that we picked. So this is a perfect situation to use a parameter. So inside the script element, let's create a new function to reuse all of this code. We'll type function, and let's name this function play game, brackets and curly brackets. Next, let's move all of this code inside the function so we can reuse it. We'll select this code and then right-click, cut, and inside the function, right-click and paste. And if we need to reformat, we can select these lines and press tab. So the value that is different for each button is the move that we picked. So we're going to turn this move into a parameter. So at the top, between the brackets, we're going to create a new parameter. Let's name it player move. And now let's save a value into this parameter. So inside our scissors button, we're going to call this function and run all this code. So let's type play game and call this function. And for the scissors button, let's save the string scissors into player move. To do that, we'll type between the brackets here and type the string scissors. So as we learned, this will save scissors into player move. And now we can use player move just like a variable in the function. Now let's modify the code based on the parameter. So here, this code calculates the result. However, this only works if the player move is scissors. So we're going to put this in an if statement. So we'll type if player move equals scissors and curly brackets. Inside this if statement, we're going to put this if statement. So let's select this and then right click, cut, and then inside here, right click and paste. And select these lines and press tab. So notice that we can put an if statement inside another if statement. And we did this because this code only makes sense if the player move is scissors. And finally, let's modify the code that displays the message. So here, instead of displaying scissors every time, we're going to display whatever is saved inside player move. So we'll replace it with $, open curly bracket, close curly bracket. And in between, we'll insert player move. And that's it. We modify this function to use a parameter instead of always using scissors. Now let's save and click the scissors button. And you'll notice that it works. We display the move scissors and we calculated the result correctly. Let's press OK, and we're going to use this function to reuse the code for the other buttons. So we'll scroll up, and for the paper button, we're going to use a different if statement to calculate the result. So let's actually copy this into the function. We're going to right click, click copy, and then inside the function, we're going to create another branch if the player move is paper. So here, let's type else if brackets and curly brackets. Inside this condition, we're going to check if the player move is equal to paper this time. And then inside these curly brackets, we're going to paste the if statement we copied earlier. So right click and paste. And we can select these lines and press tab to reformat. So now we have the code that determines the result for paper. Down here, we don't need to modify this code because we're always displaying whatever is inside player move. Finally, we can scroll up to the paper button and remove all this duplicated code and just use our function, play game, and we're going to pass paper inside. So now paper will get saved inside player move, and it's going to run this if statement instead. If we save and click the paper button, in this example, I picked paper, computer picked rock, and it calculated the result correctly. Let's press OK, and use this function for the rock button. Feel free to pause the video if you want to try it yourself first. So let's scroll up to the rock button, and first we need to copy this if statement into the function. So let's right click, copy, and then inside the function, let's create a branch for rock. Else if player move is equal to rock, and then curly brackets, and inside here we're going to right click and paste the if statement we copied earlier. And now let's select these lines and press tab a few times to reformat. And again, this doesn't need to change. The last step is to scroll up to our rock button, and instead of duplicating all of this code, we're going to remove it and just call our function instead. Play game, brackets, and then inside we'll have the string rock. Now let's save and click the rock button. So I picked rock, the computer picked paper, and we calculated the result correctly. Let's press OK. So by using a function with a parameter, we were able to reuse all of the code in our buttons. And you can see that it made our code a lot cleaner. So lastly, notice that inside a function, we can call other functions. Let's go through the code step by step so that we understand how it works. So here, when we call the play game function, we go inside here, and then we call the pick computer move function. So now we're gonna go inside this function and run all the code. And then when this function returns, we're gonna return back to where we called it, and then keep going and run the rest of the code. And then when the play game function finishes, it's gonna return back to here. So inside a function, we can call other functions. Now, one last thing we're gonna do for this code is we'll slow down, and we're just gonna add some new lines to this if statement to separate the branches and make the code a little easier to read. And save. And let's scroll up. And that's the end of this lesson. In this lesson, we learned about functions, which let us reuse code. We learned how to get a value out of a function using return. We learned how to put values into a function using parameters, and we improved the code for our rock, paper, scissors project by reusing the code and removing duplication. Here are some exercises you can do on your own to practice using functions. In this lesson, we're going to learn another type of value in JavaScript called objects. And we're going to use objects to create a score in our rock, paper, scissors project. First, let's create a new file for this lesson. We'll go to our code editor and click this icon, and then click this icon to create a new file. And we'll name this file 08-objects.html and press enter. Next, we'll copy all the code in functions.html to objects.html. So we'll type here and press Ctrl A or Command A to select the code, and then right click copy, and in here, right click and paste. Now let's hide the files for now, and we'll prepare this file for this lesson. So we can change this to objects and remove all the code in the script element. Finally, let's save and open this in Live Server by right-clicking, open with Live Server. And let's also open the console on this page. So we'll right-click, click Inspect, and click the console. Let's close our previous tabs and also the previous code. And now we're ready to learn objects. So what is an object? An object groups multiple values together. Let's do an example and create our first object. We'll go to the script element and we'll create a variable using const, and we'll name this variable product and make it equal to open curly bracket, close curly bracket, and semicolon. So this is an object. Inside this object, we can add some values. So we'll type enter, and then name, colon, and then a value, string socks. And at the end, we'll type a comma, and then price, colon, and another value, like the number 1009. So inside our object, we just added two values. So at the bottom here, let's try console.logging this object. Console.log product and save, and it will display both values into the console. So as you can see, an object lets us group multiple values together. So for each of these values, we have some code on the left. This code is called the property. And using the property, we can access specific values in the object. For example, let's type and enter and console log. We're going to type the object product, and then a dot, and then a property like name. So dot name will access the value that is associated with the name property, which is the string socks. So if we save, it will display the string socks in the console. Let's do another example, and we'll access this second value using the property price. So we'll type enter console.log the object product, and then a dot, and then a property price. So this will access the value associated with price, which is 1090. If we save, that's what gets displayed in the console. Now we can also use the property to change a value inside an object. To do that, we're going to type the object's name, product, and then dot, and a property like name, and just make it equal to something else, like the string cotton socks. So this code will change the value associated with the name property to cotton socks. So at the bottom, if we type console.log the product again and save, you'll notice the value associated with the name property was changed to cotton socks. So that's how an object works. We group multiple values together, And then we can access or change these values using the properties on the left. Now let's learn the syntax rules for objects. To create an object, we start with an open curly bracket and end with a closed curly bracket. Inside the object, we can put multiple values. For each value, the code on the left is called the property. This is how we access the value inside the object. We separate the property and value with a colon, and this is called a property value pair. We can have many property value pairs in an object, and we separate them with a comma. To access a value inside the object, we type the object's name, and then dot, and then the property we want to access, like name. This will give us the value associated with the name property. This syntax is called dot notation. If we access a property that doesn't exist, the value will be undefined. To change a value in an object, we can use the dot notation again. So product.name, and just make it equal to something else. Now using this syntax, we can also add a value to an object. We can type a property that doesn't exist. For example, here we can type product.new property and make this equal to something, like the Boolean value true. If we console.log the product again and save, it will add this value to the object along with the new property. We can also remove a value from an object by typing delete, and then the object product dot, and then the property we want to delete, like new property. If we console.log the product again and save, this code will delete new property from the object. And lastly, notice that an object is just another type of value. We can save an object inside a variable, and we can also console.log objects. If we check the type of this value, so type of product, and save, and scroll up in the console, it will tell us that product is an object. So let's remove this and save. And now we'll learn why we use objects. So objects make our code more organized. Instead of creating a bunch of variables for the product's values, like the name and the price and other details, we can just group all these related values together into one object. Objects also allow us to use multiple values together. Instead of console.logging each of these values individually, we can just console log the whole object and display all the values at once. So objects let us group multiple values together and let us use multiple values together. Next, let's do a practical example with objects. We're going to add a score to our rock, paper, scissors game. So I've actually prepared a project we can use for this lesson. To see this project, we're going to go to our website and then create a new tab. And then up here, we're going to type supersimple.dev/projects/objects and press enter. So this is our simplified rock, paper, scissors game again. Except in this project, when we play the game, it's also going to keep track of a score. So how many times we win, lose, and tie. And also, if we click OK, we have a reset score button. So if we play the game a few times and add to our score, and then click the reset score button, this will reset the score back to 0. So if we play the game again, the score starts from 0 again. So we're gonna learn how to use objects to create this feature. Let's press OK. And first, let's create a copy of our project just for this lesson. We'll go to our code editor and click this icon to show our files, and we'll make a copy of the rock, paper, scissors project from the previous lesson. So we'll right click and copy, and down here, right click and paste. And we'll right click and rename this file. We'll remove the copy at the end, and at the front, we'll change this to 08 and press enter. Now let's hide these files, and we can close the 07 file for now. And let's open this in Live Server by right clicking and open with Live Server. Let's also open the console on this page. So right click, inspect, and the console. All right, now let's go into our code and add a score to our game. So remember, when writing JavaScript, a good strategy is to think about what steps we need to do. This is called an algorithm, and then convert those steps into code. So we already had an algorithm for the rock, paper, scissors game. Let's update this algorithm to include the score. So first, the computer randomly selects a move. This step will stay the same. Number 2, we're gonna compare the moves to get the result. This step will also be the same. But now, we're gonna add an extra step. After getting the result, we're gonna update a score. And finally, we'll display the result and the score in a pop-up. Now let's convert these updated steps, or this algorithm, into code. The first thing we need to change is we added a third step. We're going to save and update a score. So first, we need somewhere to save our score. So one place we can save it is inside a variable. Let's go to our script element, and at the top, we're going to create a variable for our score using const score and make it equal to an object. And inside this object, we're gonna have the property wins. So this will keep track of how many wins that we have. We'll type colon and the number 0, because the score starts at 0, and then a comma, and then another property, losses. This will be how many losses we have, and then colon and 0, and then another comma, and ties, colon and 0. So we use an object here because these values are related to each other. You could use separate variables, but we're using an object for convenience. Another thing you'll notice is that we're creating this variable outside of a function and outside of a scope. And that's because every time we make a move, we need to update the score from last time. So in order to save the score from last time, we need to keep it outside the function. If the score was inside the function would create a new score every time, which is not what we want. So in this situation, in order to save a score from last time, we're going to keep this variable outside. Now, every time we play the game, after we calculate the result, we're going to update the score. So let's scroll down to where we calculate the result, which is here. And then below it, we're going to type some new lines and type the code for updating the score. So we can do that with an if statement. So we'll type if brackets and curly brackets, and inside the condition, we're going to check if the result is a win. If it is a win, we're going to update the wins property and increase it by 1. So down here, if the result is equal to the string you win, and make sure that this string matches the string up here, inside the curly brackets, we're going to update score.wins, and we'll make it equal to itself plus 1. So this is how we increase the wins property in the score object by 1. Now remember from the variables lesson that we have a shortcut for increasing something by 1. And that shortcut is plus